Welcome back to the second session this morning. We've got another 4 speakers for you, really just to capitalise on really what we've been talking about earlier on today. Obviously, we've had some really impactful sessions this morning, so I'm going to challenge Arun to provide another one. So I'll hand you over to Arun from Applied Levidian Technologies.
Yeah, thank you. Thanks, Sean. Good morning, everyone, and thank you for the introduction, and thank you, The Geek, for providing me the opportunity to present in here. So I'm from a company called Levidian, and I'd like to introduce about Levidian and what we do and how our technology is actually helping accelerating decarbonization of carbon-intensive industries. So who we are? So Levidian are a British climate technology business who's predominantly focusing on decarbonizing the world's most carbon-intensive industries. So we are relatively a new company, just started in 2012, but then we have a very long technical heritage where, as Cambridge Nanosystems, our technology is being formed there. And then in 2020, change of ownership, we became into Levidian, what we are right now, turning the entire decarbonization as a service, as a model, and then providing that to a lot of hard-to-abate sector industries. So currently we are over 80 people. We started off as 6 people in 2021. We are currently in the scaling up journey at the moment of how our technology is being scaled up in terms of the technology behind and how they utilize it in all over the world right now. So we have currently expanded into a regional, into the global footprint of UAE and also recently into the Northern Americans. So what is our decarbonization solution? So we are into carbon capture, carbon prevention, and also in carbon utilization. So we are creating a commercial value through a pre-combustion carbon capture of a methane source. So not by just offsetting the carbon costs, but also providing a valuable venture, a profiting venture. And also carbon prevention. So we are actually reducing the carbon dioxide emissions by producing hydrogen on site as an alternative for a fossil fuel, as a clean energy source. And also, obviously, the carbon utilization comes from by enhancing the performance of your products and by improving the carbon footprint by the utilization of the graphene that we actually produce. So this all acts as like a multiplier for the entire decarbonization as service, as a model, and everything is powered by what we have. The technology is called the loop. So what is a loop? So basically, loop is a decarbonization in a device box. It works on a principle of using microwaves to ionize the gas, which is methane. So that methane feedstock can come from any type of methane. So it can come from the natural gas, which is the grid gas, or it can come from the flare gas, as Kostios touched upon earlier in the talk, and biogas and landfill gas. So basically, what we do is the methane that ionizes the plasma, ionizes the gas into it, and it creates carbon and hydrogen, and the carbon is then stripped off in form of the graphene materials. And the hydrogen is then is in the exhaust gas as a hydrogen-rich carbon gas, which you can further purify to remove the hydrogen, so have a pure hydrogen production, or you can utilize directly the hydrogen-rich blend gas in the utilization and the blend gas itself. And then obviously the graphene is then being utilized in many, many applications at the moment. So the entire decarbonization effort can be even furthered by if we were to use the hydrocarbons back into the loop itself. That's one of the active R&D that we are currently utilizing. So as an example, for a single pass through our reactor, so the decarbonization potential is up to 40% of carbon dioxide emissions. So in terms of where we are right now, so in terms of the scaling up journey, so the very first prototype that we have made is a Loop 10. 10 is 10 kilowatts to run it. So at the moment, that is actually first of the adapters are the Khalifa University. It's actually sitting in the UAE at the moment. But at the moment, we have the routes to produce our Loop 1000, which is in the next year. So that is actually can produce up to roughly around 200 tons of hydrogen and for 200 tons of carbon itself. That is one particular module on one place. So you can see the real potential of this particular technology, not only decarbonizing and also producing the hydrogen and also the graphene at a bulk scale. So a couple of case studies I'd like to highlight specifically on the loop usage. So this is particularly very interesting because it's with the United Utilities, one of the largest water, let's say, utility company within the Northwest. And this is deploying the loop in decarbonizing the biogas, which is coming from the wastewater sludge treatment plants. So in fact, it's very exciting because the loop, this is the largest of the loop that we actually built, which is a Loop 100. It's a pilot scale, and it's actually got delivered to Manchester in the Bioresources Center on Friday. So it's actually within the premises of 20 minutes from what we are doing now. So over the course of this trial, it's actually a funded project by the Department of Energy and Security Net Zero. It's predominantly a hydrogen sort of a project where we have the carbon utilization or carbon capture and utilization comes in as a very important feature as well. So over the duration of the project. So this would have a potential of nearly 112,000 meter cube of biogas processing, and that is equivalent to produce around 50 tons of biomethane and then around tons of hydrogen as well. So the carbon, that is graphene that's produced from this particular project, would be utilized for predominantly for R&D purposes, mainly into the paints and coatings formats or into concretes and so on and so forth. And the second one we are working on is on the landfill gases. This is again as a demonstration to prove our technology on-site in the landfill sources. So this is particularly with the UAE company called Tadweer. They are the leading waste management company in the Middle East. So in here, this is again a predominantly a loop project where we are focusing on showcasing the technology in capturing the landfill gas and then converting that into two valuable products. So it's the hydrogen and also the carbon as well. So over the course of, again, this particular trial, we would have actually produced or captured, let's say, 10,000 cubic meters of landfill gas in the very first 10 months. And then obviously the ambition is quite high by deploying different loops. And then around 25 tons of carbon dioxide equivalent will be saved, and nearly 4 tons of hydrogen would be produced in the trial. And this particular hydrogen would be used to produce cleaner electricity within their whole infrastructure itself. So this is the type of sort of the loop projects that we are working on right now. So the focus of the company right now is scaling up on the loop side and strategically placing this loops on different areas for to prove the flare gases and the biogases and so on and so forth. So in terms of the graphene, so the carbon that comes out is actually a graphene type material, which is one of the highest quality materials. It's highly carbon, so 99% is sp2 carbon. And because of the production process itself, it's very unique morphology. It's not flat-like, so it's a crumpled, unwrinkled, flat-like material. So a very narrow size distribution because of there is no moving parts at the moment. So it's a very scalable production process. So we have done a lot of characterization, in-depth characterization of the material that comes from different type of loops all over the world, and we have actually got very good consistency across the complete characterization of it. So it's a scalable process, and this actually takes out the let's say the confusion in terms of how scalable the process can be, how consistent. This is one of the biggest challenges has been happened within the graphene adaptation. And depending on the type of, let's say, the power used, and also depending on the type of the gas that's being used, it can be actually carbon negative as well. So a kilogram of graphene produced will be a carbon negative materials. And in terms of it is very low cost in a way that because it can be produced on site as and when required for the particular customer. So you can actually deploy the loop, not only decarbonizing your gas process, but also at the same time having your valuable carbon material itself. In that way, that is a holistic approach of having the decarbonization and the utilization of the material itself is a valuable proposition for many of the customers that we are working with. And of course, we are one of the verified graphene producers by the Graphene Council as well. To that. So in terms of application itself, so Applied Technologies, that we are the team, we are relatively new, so a couple of years are under just a couple of years, and we work very closely with the Geek application development team as well. So we focused predominantly on high bulk volume market applications where predominantly the carbon is used. And one of the areas I want to highlight is on the tires as well. So within the tires, it's specifically on, so we worked independently with a third party. So people technology called TARC or Rubber Consultants. They are based in Brickenbury in the UK, who are very well known for their formulation efficiencies in terms of the tire production and tire development, to be honest. So we worked with them on the truck tread formulation, where we have able to incorporate our graphene into a standard truck tread formulation using the industrial processes that would be typically used in the tire industry. And what we were able to achieve was to totally reduce the total carbon content, that is the carbon black content, significantly. And what it enabled you to do is not only having the similar physical properties and mechanical properties you need for a truck tread, but also at the same time, it enabled quite a lot of significant improvements in the permanent deformation, that is compression set, and also the other properties because of the graphene. And also the dynamic properties, which is the rolling resistance. So rolling resistance, of course, it turns into the efficiency. And what is the fuel efficiency? You're able to really increase around 23% of increase in rolling resistance. And at the same time, we were able to, because of the reduced carbon content, we were able to reduce the total weight of the tire tread, that equivalent to around quite a lot of savings, potential savings within the tires itself. So we actually produced this demonstrated tire, which you can see downstairs if you want to learn more about the tire and how it can be utilized. And that's one of the active areas that we are working on into tires, truck treads, and also the passenger tires. Other exciting work that we did is with the medical gloves. So this particular work has been a collaboration between Levidian, Cranfield University, and a company called Meditech Gloves, who are one of the medical grade glove manufacturer. And in the process of them working out a sustainable way of producing the gloves, at the same time they were exploring the use of the sustainable materials, and they have utilized our graphene in the production process. And with very little graphene, so less than 1.1%, not only they were able to increase the performance of the gloves itself, but also it has improved the process efficiency of how they make the gloves. And also added advantages that they were able to see, it actually degrades faster. A typical latex glove have degraded under the soil for over 2 years, and whereas the graphene enhanced was just over a year. So there was nearly 45% reduction of degradation, and then currently there is one of the PhD work is going on to understand why is that case in the moment. So at the stage right now, so they've actually produced over 500,000 of these gloves, and currently that are being tested and also going through a significant, very comprehensive accreditation facility, and for the launch in the later of the year. And in terms of the polymers and batteries, I'll touch upon. So basically, within the polymers sectors, within thermoplastics itself, we've looked into different, obviously the different pyramids of where we can add the graphene into. So one of the things within the commodity type plastics, in the HDPE type plastics, it's predominantly on the mechanical performances. So we worked with Borouge, is one of the major manufacturer of the polymers themselves, based in the Middle East. So they have tied our graphene into their products, which is part of the PhD study, and they were able to show that the graphene was enabling a huge improvement in the mechanical properties, and that's predominantly would be looked into for a polypipe application, where can we actually increase the size of the pipe, or perhaps even increase the pressure of the pipe inside it. And other areas that we're looking at is TPU and also the PA6, but particularly on PA6, mainly because of this permeation facility. In the PA6, it's much more on very little amount of graphene have improved the mechanical performance. That's mainly on the impact performance. And also, again, on the reduction on the permeation, that is nearly 25% reduction in hydrogen as well. So that is, again, could be used for the hydrogen permeation sort of studies. And within the peak, high performance plastics, it's much more on the electrical conductivity rather than the mechanical performances. With a modified version of our graphene, we were able to get a very good percolation, very low percolation, in fact around 3% within the peak, and we were able to obtain nearly 10 to the power of 3 ohms meter volume resistivity at a very low weight percentage as well. So on that, currently some of our partners are looking at lightning strike production sort of application. And in terms of rubbers, there is thermosets as well. As I mentioned, our predominant focus currently is on tire-based because of the entire supply chain and decarbonization as a model. And within that, we are also looking into passenger tires, as I mentioned. Within the passenger tires, it's predominantly silica filler-based, but as carbon black is only added as a UV resistance and also to give the color. And we have tried replacing that carbon black with our graphene materials and have very good summer performance, and also added advantages of wet grip, and also additional improvements such as electrical conductivity and anti-ozone type application, which is one of the prime area of research within the passenger tire markets because of banning of certain chemicals. And then other one which I want to talk about is on the FKKN type materials, which is predominantly used in high temperature sealing type applications, and with very little amount of graphene that's been added, is around 1-2%. They were able to see a significant improvement in the tensile or also sealing performance, and not only that, and they were able to see an improvement in the compression set at elevated temperatures, which is an operating temperature improvement, and that is much more exciting for the customer themselves. So, and also the other areas that we're working on, which slowly touch upon, because within the battery sectors, most of the works that are being carried out are in collaboration with an external company, so it's covered in NDA. But slowly we started looking ourselves into what are the different chemistries that we could potentially use in our graphene into. So one of them is on a LFP sort of a chemistry, on a 9622, which is an industrially relevant sort of recipe. that actually trying to compare or as a filler, it's not as an additive, as a filler, removing a significant percentage of the carbon black out and then including our graphene in, and then we were able to see some nominal improvements in the specific discharge capacity of our G3. So that gives you. So I think I've covered the entire the story of where we were, and then what's our business model, and also giving an overview of what we are doing at the moment, touching into the applications and the loop case studies and things. Quite a lot to cover. So I'm very happy to answer any questions, and we have an extended team as well who are present here for covering from commercialization, also business development. So please feel free to come and reach out to any of us. Thank you.
Thank you very much, Arun. Any questions, please? Which has been very comprehensive.
I think I've nailed it.
Well, again, very, very important message about decarbonisation. Oh, so we do have one on the front.
So, prior with your meeting, you mentioned about spring as laws. Are you thinking about the happening in business? The biodegradable, what is the mechanism?
That's exactly what we're trying to find out. So it looks to us that it breaks down faster. At least in the images that the researchers have taken down, it breaks down faster. So what is it breaking down faster? Is it because of what's been changing within the glove chemistry itself, or how the degradation itself is happening? Is it enabling? Is it starting as a nucleation point for the breakdowns to happen itself? So that is exactly what we are trying to find out at the moment. But it's very interesting even for us. It was something as a part of the sustainability study. They actually try to understand like how does it work, and then this is one of the things they found out. So. Quite interesting.
Thank you.
Thank you.
Any further? No? Oh, Hassan, one more.
Okay, thank you very much. We did have to read about Gabik and the Dean behind the events. I'd like to ask you a question of you, and I'm not serious now that you set up CAM in the US of nice. Well, your bit solid defense on free elements of panic value, the removal of waste, induction of hydrogen, and production with graphene. If you can, then let's be to allergies with one is game time. With the different customers that you installation for VC elements speed is the
I mean, in general, it's currently, when it was the beginning, it was much more on the utilization of the carbon itself. But then it's currently slowly the companies are coming around in the utilization of the entire as a holistic approach. It's looking at all the three together and how it's actually adding the value to the business itself. It's the entire decarbonization itself, how they decarbonizing their carbon inputs, and they're able to see the carbon credits that can be generated off, and also at the same time producing the hydrogen, which can then remove. They are able to utilize that particular hydrogen itself, and also the utilization of carbon towards the end. So they currently the industry, for example, the tire industries are really seeing the benefits of the entire approach because they use a significant amount of gas in their processes. So yes, it was predominantly focused on the carbon, that is the graphene value, but now I think it's slowly getting to the entire holistic business model that we are bringing.
Okay, thank you very much, Arun.
Thank you, guys.